everyone. Myself Sravanthi, working as the assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today my topic is parse tree. Here I am going to discuss what is parse tree, what are the types of parse trees we have with an example. So here what is parse tree? So here parse tree is nothing but we can also call these parse tree as a derivation tree. We can call this parse tree as a derivation tree, or we can also call it as a syntax tree. In the phases of a compiler, the syntax tree is nothing but we are going to derive a tree structure. That is nothing but we'll be calling it as a parse tree. So the parse tree is nothing but we'll be calling it as a derivation tree or parse tree. So here the tree, it looks like a hierarchical representation, or we can also tell it as a graphical representation, how a string is derived by from the start symbol of a grammar by applying some production rules. So typically these production rules are derived from the context-free grammar. So here we are going to derive the string by applying the parse tree, nothing but we are going to take the start symbol, and by applying the start symbol, by applying the production rules for the start symbol, we are going to derive the given string by applying these production rules are typically taken from this context-free grammar. So nothing but here the parse tree is nothing but the syntax tree we can call, and we can also tell it as a derivation tree. So this tree construction will be done by taking the start symbol, and we are going to derive the start symbol by applying the production rules in order to generate the given string. So there are some rules that we need to follow in order to generate or in order to derive the parse tree. So the rules are the root node should be the start symbol of the given grammar. So I'm having a grammar. In that grammar, there are production rules. In that production rules, I need to take the production rule which is having the start symbol. So the start symbol should be our root node. So the internal nodes are nothing but the non-terminal nodes. So the non-terminal nodes are, we can also call those as variables which will be in a capital letters. The non-terminal nodes will be in a capital letters. All the leaf nodes are terminal nodes. All the leaf nodes are terminal nodes are nothing but the leaf nodes will having the small letters, or it will be consisting of terminals. So nothing but it will be represented in the small letters. Non-terminal nodes will be in the form of a capital letters. The root node is nothing but the start symbol of my production. So by applying those rules, we will be deriving the trees. So there are two types of derivation trees, are the leftmost derivation tree and the rightmost derivation tree. So we have already seen these derivations, leftmost derivation and rightmost derivation. So coming to here in this derivation tree or the parse tree, we are going to derive the parse tree by applying from the leftmost derivation. From the leftmost we will be applying, and coming to the rightmost derivation tree is nothing but we will be applying from the right side. So the terminals, the non-terminal will be replacing is done from the right side. So that is the difference for the leftmost derivation and rightmost derivation. So first example, E produces E plus E star E, ID. So I need to derive derived tree or parse tree to obtain ID plus ID into ID. I need to derive this is the string by applying the parse tree. So what is the parse tree? The rules we are having is the root node should be our start symbol, and the internal nodes will be our non-terminal nodes or variables, and the leaf nodes should have the terminals. So the terminals are nothing but the small letters we will be having here. So first the start symbol I am having is the E is my start symbol. So now I can take E plus E or E star E. I can take anything, E plus E or E star E. So if I can take E plus E plus E. I'm going to apply here the leftmost derivation tree, nothing but leftmost parse tree I'm going to generate here. We can, if you want, we can generate from right side, nothing but the rightmost non-terminal should be replaced first. Here I'm replacing it from the leftmost non-terminal, so that is nothing but leftmost derivation. So E plus E. E can be replaced it with ID. E is replaced with ID. Why? Because the first string I'm having is ID. So plus ID plus. So this E can be replaced with what I am having here, ID into ID. So I can replace these non-terminal E with E plus E or E star E or ID. But I cannot replace this E with ID. Why? Because I am having two more characters are there, that is nothing but ID into ID. So here the operator I am having is multiplication operator. So that is the reason I am going to take this production rule E into E. E star E. E star E. So now ID E can be, the E non-terminal can be replaced it with ID or E plus E or E star E. So but for me I'm having is the second string is ID. So I'm replacing it with ID. Next ID into, next one I'm having is ID. So what I got here, the string is complete, ID into ID. So the string is ID plus ID into ID. So by applying the leftmost derivation, I have derived the string id plus id into id. So let me apply the rightmost derivation. So this is nothing but the leftmost derivation tree or the parse tree, leftmost tree. So let me apply the parse tree for the rightmost. So here E produces, let me take here E star E, E star E, or let me take the same thing E plus E, E plus E. So here I'm in the first one here I have derived the star from the leftmost terminal. Now I am deriving it from the rightmost terminal. So here what I'm having the operator I'm having is multiplication. So I can derive this E non-terminal by applying the E star E instead of E plus E. So E star E, E star E is derived. So now I have completed ID plus ID into ID. So the last string what I'm having is ID. So this E is replaced with ID. So the next, this is a non-terminal. So the next non-terminal I'm having is here E. So this E non-terminal can be replaced it with ID. And next these two terminals are completed, non-terminals. So the next non-terminal I'm having is E. This E can be replaced it with ID. So the string I'm having is ID plus ID into ID. So I got the same string by applying the leftmost and the rightmost parse tree. So let us go for one more example. S produces L or A. L produces brackets L comma S or S. So derive the tree or the parse tree to obtain A comma A. So I need to derive this parse tree for by applying these production rules from the given grammar. So yes, so the production rules to start from nothing but the parse tree derivation should be done from the start node. So the S is my start node. So S produces what I'm having here, L brackets open close L. So this L I can replace this L with A, L can be replaced with S, or L can be replaced with L comma S. So with what I need to replace? If I replace this L with S, I will be getting only single A. But here I am having A comma A. Whenever we derive the strings, we need to check the given string is what. Based on that string, we are going to derive the string. So here L is there. L I can replace it with L comma S. L comma S. So here the L comma S. L is derived by applying L comma S. If I derive S, I will be getting only one string, that is nothing but only one character A. But I am having A comma A. In order to derive this string, I need to apply this production rule. So the next one is L. So L again I have L comma S or S production. So I will be taking S production. Why? Because I got in the form of the given string. So it is replaced with S. It is replaced with S. So S can be replaced with open and close bracket L or A. So I will be completing it with A because I am having A string. A comma A. So only the non-terminals are going to be derived. The leaf nodes will be the terminal nodes. So open bracket, close brackets, small letters, all those will be the leaf nodes. Open A comma A close bracket. Open A comma A close bracket. So this is the given string which I have generated by applying these production rules for the parse tree. So the next one is S produces B S B or A or B. So derive the string BB BB string. So S is my start symbol. So what I am having here, B S B, B S B. So I can take this production or this production or this production. But I need to generate BBA BB string. So in order to generate this, I need to take this string as the thing. So BSB. So B is a terminal. So there is no derivation. For S is a non-terminal. So again I am going to derive it BSB. BSB. So I got here two B's. So in the right hand side also two B's are there. So I will be deriving S with either A or B. But I have here A, so I am going to derive S with A. So B, B, A, B, B. So B, B, A, B, B is the string which I got here. So the next one, derive tree or parse tree to obtain A, B, 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 B string. So what is the start symbol I am having? S is my start symbol, A and B is the thing I have taken. So the start symbol I am having two production rules, AB or epsilon. So I am taking AB because in order to derive the string A, B, B, A B B B B string in order to derive it. So AB. So what I am having, the first string I am having is A produces AB. A produces AB and B produces SB. B produces SB. So I can take anything. So I am applying the left progression. So I am taking this one. A produces AB. A produces AB. So the first string, first character A I have got. Again I am reproducing this B. So nothing but A. Again B I got. So nothing but two A's I got. A I got. So the next B I can replace it with SB. I can replace this B with the SB I should replace. So B is replaced with SB. SB I replace. So how many I have? Here four B's are there. So in the same way I need to derive this one. So S produces A, SB. B produces SB. So again this S I can replace it with AB or epsilon. I can replace this B with AB or epsilon. So what I can do here? So here I can derive this B with, I can, so here the start symbol is S. S produces A and B. S produces AB. So A is nothing but, here I am having the production rule is A and B. A is having the production rule AB. So here the B production, A is the terminal, so it is the leaf node, we are not going to derive it. So here it is B is there, so we are going to derive the B. So B is nothing but B produces SB. B produces SB. B produces SB. Again here S can be derived with AB or epsilon. So let me derive S with A and B. S can be derived with A and B. So here the A can be replaced with AB. A and B. So how I am deriving this? I am having the strings are AA. So the first string A I got. So the next one is B is there. So B is a non-terminal. So I am replacing B with SB. So the last symbol B I got. Here again I have S. S is a non-terminal. Again I am deriving this S. So S can be replaced with AB or epsilon. But here the given string is I am having many characters. So I'm deriving S produces AB. So S produces AB. Again A is produced. A is produced with AB only. So A. So two A's I got here. So the now the B can be replaced with SB. So B can be replaced with S and B. B can be replaced with SB. So here again I have S. So S can be replaced with AB or epsilon. So I cannot replace S with AB. Why? Because again in AB I will be having A as there. So already I read two A's I have completed. So I cannot take this A. So I can replace it with epsilon. S is replaced with epsilon. So the next again this part is completed. So again I will be checking the next non-terminal. So this is the non-terminal I have. Again it is replaced with A. B produces SB. So again this S is replaced with non-terminal. S is replaced with non-terminal. Two A's I read. A I completed. So epsilon B, two B is completed and the next B is also completed. I am left over is with B. So B should be replaced with S and B. So this S I can replace it with epsilon. So I got this one. So B, sorry, A, B, 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 B. So nothing but A, B, B, 4 B's. So this is the derivation which we got by applying this production rule for the given string, and I have generated the parse tree. So here we have discussed what is a parse tree. Parse tree is nothing but we can call it as a syntax tree or we can also call it as a derivation tree. To derive the parse tree or to derive the syntax tree, we are having few rules. That is nothing but the root node should be the start symbol and the internal nodes should be the non-terminal nodes or the variables, and the leaf node should consisting of the terminal nodes, that is nothing but the small letters. So by applying these rules, we are going to derive the parse tree. So we can derive the parse tree either in leftmost derivation tree or we can also apply the rightmost derivation tree in order to generate the given string. Thank you.